It's hard to think of anything simpler than a circle, but somehow the shape became the backbone of civilization. Without it, there'd be no cars, no bikes, no machines, no clocks. Honestly, no modern world at all. What's wild is that for tens of thousands of years, humans built tools, made fire, even created art, but not wheels. It took us ages to figure out one of the most obvious shapes in nature, and when we finally did, everything changed. The wheel wasn't just an invention, it was a turning point, literally. It transformed how we moved, built, traded, and even thought about motion. But here's the real mystery. Why did it take so long? And how did one simple idea spread from a wooden disc to the high-tech wheels carrying rovers on Mars? Before the wheel, moving anything heavy was slow, painful work. Transport depended entirely on muscle, human or animal. People dragged stones with ropes, pushed sledges across the ground, or rolled loads over logs. It worked, but it wasted enormous energy. Every step forward meant fighting friction. In early civilizations like Mesopotamia or Egypt, construction projects and trade relied on massive labor forces. Moving a single stone block could take hundreds of workers. Over long distances, it was nearly impossible. Land travel was limited, and most goods followed rivers because water was the only efficient way to move heavy loads. This shows just how critical the missing idea was. Humans had already built tools, made pottery, and even sailed, yet we still hadn't mastered a rolling motion on land. The concept of a surface rotating around a fixed point, turning dragging into rolling, hadn't fully formed. There were hints though. Logs were sometimes placed under objects to help them move, showing that early people understood the benefit of rolling. But a true wheel, one that spins freely around an axle, was still centuries away, and the breakthrough didn't come from transport at all. It started with something far more ordinary, shaping clay. The story of the wheel begins, surprisingly, not with transport, but with pottery. Around 3500 BCE, in ancient Mesopotamia, craftsmen discovered that a rotating surface made shaping clay much easier. These early potter's wheels were simple stone or wooden discs spun by hand, but they revealed something powerful. Continuous circular motion could make work faster and smoother. This was the first real step toward the wheel as we know it. Once people saw how effective rotation could be, the idea slowly expanded beyond pottery. The concept of a disc spinning around a fixed point opened the door to new possibilities, but applying it to movement wasn't easy. A potter's wheel stays in one place. Turning that same principle into a moving vehicle required a second invention just as important, the axle. A wheel alone doesn't help if it can't rotate freely while carrying weight. The combination of a wheel and axle was the real breakthrough, a piece of engineering that turned a static circle into a tool for transport. And it's in this moment, somewhere in Mesopotamia over 5,000 years ago, that humanity created its first true wheel, a solid wooden disc, heavy but functional, built to roll. From there, everything started to move faster, literally. Once the idea of rotation took hold, it didn't stay in the workshop for long. People began applying it to transport, and that's when the first true wheels appeared. Archaeological finds from Ur and Uruk in ancient Mesopotamia show solid wooden wheels attached to carts around 3500 BCE. These were made by joining 3 thick planks of wood, shaped into a rough circle and fastened around a fixed wooden axle. They were heavy, some weighed over 20 kilograms, but they didn't need to be fast. What mattered was that they could handle weight. With these carts, a single worker and an ox could move what once took dozens of people to drag. Suddenly, it became possible to haul grain, clay, building stones, and trade goods far more efficiently. It was a quiet revolution, not flashy, but deeply practical. The design spread fast because it worked. In Central Europe, wheels found at Brnocica in Poland show similar construction, solid wooden discs used for farming and transport. In the Indus Valley, wheels appeared on small carts used in cities like Mohenjo-Daro, helping move goods through narrow streets and bustling marketplaces. What's interesting is that every culture that adopted the wheel adapted it. In fertile plains, wheels stayed large and heavy to handle thick soil and rough ground. In cities, they became smaller for tighter turns. These early wheels weren't mass-produced, they were crafted, shaped to fit local needs. Even the materials told a story. Builders chose dense, durable wood like elm or oak, and early axles were greased with animal fat or oil to reduce friction, primitive lubrication that made rolling smoother. The concept of mechanics was being discovered one step at a time. By the end of the 4th millennium BCE, the wheel had become essential for agriculture, trade, and construction. It changed how settlements connected and how economies grew. But as people started using carts more often, a new question emerged. Could wheels do more than carry weight? Could they also bring speed? The first wheels solved one problem, moving heavy loads, but they created another, weight. These solid wooden discs were strong but slow. As transport grew more common and trade networks expanded, people began to look for a way to make wheels lighter, faster, and more efficient. The breakthrough came around 2000 BCE with the spoked wheel. Instead of a solid block of wood, builders used a rim connected to a central hub by wooden spokes, cutting the weight dramatically. This design allowed wheels to spin faster and handle rougher terrain without breaking. The earliest known spoked wheels appeared in Mesopotamia and quickly spread to Egypt, the Indus Valley, and China. It didn't take long for societies to realize what this meant. The spoked wheel gave rise to the chariot, a lightweight two-wheeled vehicle pulled by horses. For the first time in history, humans had a tool that could move fast across land. Chariots became a symbol of power and technology. Egyptian armies used them in war. Hittite craftsmen perfected their design, and across Asia they became essential for communication, hunting, and display. From there, innovation never stopped. Metal rims were added to protect wheels from wear, and later iron hubs strengthened the connection between axle and wheel. Every improvement expanded what wheels could do, from farming carts and wagons to carriages and early machines. By the time of the Romans, wheels were everywhere, in transportation, water mills, gears, and early mechanical devices. They weren't just moving people and goods anymore. They were turning the engines of progress. Over thousands of years, the wheel had shifted from a tool of labor to a tool of speed and engineering, and the next lapse in materials, mechanics, and design would carry it straight into the modern world. The power of the wheel comes from more than its shape. Its brilliance lies in how it turns friction into motion. Dragging a heavy load across the ground wastes energy because the whole surface scrapes against the earth. But when that same weight rests on a wheel, only a single point touches the ground at a time. The resistance drops and movement becomes smooth, steady, and far more efficient. That simple shift from sliding to rolling unlocked a new kind of freedom. And it wasn't just about transport. The wheel and axle system introduced a completely new way to control motion. With a rotating disc spinning around a fixed center, heavy loads could move with minimal effort. That principle became the foundation of mechanical design, the same logic behind gears, pulleys, mills, and engines. Once people understood this, everything changed. Trade networks expanded as carts carried goods farther and faster. Farmers could move crops more easily. Builders could transport stone and timber, and merchants could connect distant cities. Roads began to appear, carved across continents to serve the new demand for movement. Civilizations rose on this foundation. In Mesopotamia, wheeled carts turned local trade into a regional exchange. In Egypt, chariots reshaped warfare and communication. Across Europe and Asia, wheels carried armies, ideas, and cultures farther than anyone could travel before. Even daily life transformed, from mills grinding grain to water wheels harnessing rivers. The principle of rotation powered entire economies. Over time, the wheel became more than a tool. It became a symbol of progress. Ancient cultures carved it into temples and myths, linked it to the cycle of life, time, and motion. It represented something deeper, the moment when humans stopped fighting friction and started mastering it. And as technology advanced, the same idea kept evolving. Metal rims, bearings, and rubber tires made wheels stronger and smoother. Later, they powered machines, engines, and turbines, the moving parts of industry and invention. From the first wooden disc to the wheels of modern vehicles and even space rovers, every rotation carries the same genius, a simple, elegant solution that turned effort into motion and motion into civilization. From solid wood to rubber tires, the wheel kept evolving with every era. Iron and steel made it stronger, air-filled tires made it faster, and engines turned it into the heart of machines. Today, wheels move cars, planes, factories, and even robots on Mars, all built on the same idea born over 5,000 years ago. Few inventions have stayed this pure. The wheel didn't need replacing, only refining. It still does exactly what it was made to do, turn effort into motion, and motion into progress. It's one of those rare ideas that never goes out of style, and it makes you wonder, what other inventions are so perfect they lasted since the dawn of civilization? Tell me which one you'd like to see next. That's all for today. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. You can also leave a comment with what you would like to see in the following videos. Thanks for watching, and we'll see you next time.